Hello everyone, welcome to this video where we're going to be looking at how we can use STimber to look at our support reactions after a structural analysis. So in this example, I actually have a dome structure, and this is a little bit unique from most of the frame structures we might have seen in some of the other videos, in that we have shell elements that are representing this fabric, or these membrane elements actually, and there's a frame underneath that. So we actually have supports at joints throughout the shell element. We can look at the fine element mesh if we want to see those shells in more detail. However, what I'm interested in looking at here is basically getting those reaction loads from that support location, or from those support locations. And if we just drill down and click on one of these joint locations, for example, we can see here the locations. We can also see the support, so it's a custom degree of freedom that is fixed basically in the translational degrees of freedom, but not the rotational degrees of freedom. So that should be reflected in the boundary, or in the reaction loads that we get out of this model. So I'm going to switch here to the result menu. And right now I'm looking at the member results. So I can actually locate this member results tool. And you can see here we can configure what type of diagram we want to look at. We can look at force diagrams, deflections, stresses, and so on. And I'm looking at an axial load diagram. And you may also notice here that I have this reactions checkbox that's actually already checked on. So we can toggle this on or off, and this allows us to see at each individual joint location for the selected load case that we're looking at, or load combination, what those reaction loads are at that specific location. And for this example, I'm looking at the direction Fx reactions. Maybe I want to look at the vertical reactions, Fz. And it's pretty clear to us from looking at this that we can see that there are higher support reactions at the location of these members that are coming down rather than the shell elements. And that makes sense given that they would likely have most of the load traveling through them and would naturally be heavier as well. Now if we're looking at kind of a global support reaction or base shear, we can also do that through the spreadsheet window. So if I just expand this spreadsheet window and I look at the results spreadsheet, because I've already run a structural analysis, I can access the results I'm interested in and look at the base shears. So I can see here the base shears, and this is showing me the overall force summary for my reactions. So 136.8 kilonewtons. I can also see that there's a joint spreadsheet. And if I expand this, I have the option to view displacements at my joints and also reactions at each individual joint. So this is showing me the same information that I can see graphically, just in a numerical spreadsheet. It's showing the joint that it's associated with, obviously the load case, and then the force reactions as well. Hopefully you found this useful. If you'd like more information on STimber, please feel free to check out our YouTube playlist or the training available through the Altair Learning Management System.